Okay, happy Thursday, everyone. Today is World Teachers Day, so if you've got a favorite teacher, maybe send them a thank you note today. And next week is also Fire Prevention Week, so we're going to celebrate both occasions right here today because we've got a trainer from Uponor Academy with us to discuss multi-purpose fire sprinkler systems. Now, if you haven't heard of these systems, that's okay. They're a brilliant design that combines the fire sprinklers with a home's cold water plumbing system. This unique layout not only saves on building materials, it also provides additional benefits such as water and energy efficiencies. You know what else it saves? Lives. Doesn't get any better than that. Now, our presenter today is Dan Hubbard. Like I mentioned earlier, he is the customer trainer for Uponor Academy. Prior to his role in training, he was the design supervisor for Uponor Fire Safety. Dan holds more than 18 years of experience in fire sprinkler design and has a NICET, which stands for National Institute for Certification in Engineering Technologies, Level 4 certification in water-based fire protection systems. He has an associate's degree in architectural drafting and estimating from North Dakota State College of Science. Now, during the course of today's presentation, you can submit questions for our guest. Simply use that questions box that you see over, it should be on the right side of your screen. Now, we're going to have a couple of points throughout the webinar today where we can stop and take questions, so please submit them at any time. We're also going to have a Q&A time set aside after the presentation as well. Dan, welcome to the program.
Thanks, Mike. Fabulous introduction. I'm in tears right now. Of course, you can't see them, but I am drying them off as we speak. So we are going to talk about multi-purpose fire sprinkler systems today and why they are more sustainable. I guess I gave it away there right at the beginning. Yes, the conclusion is going to be that fire sprinkler systems that are installed in a multi-purpose configuration are more sustainable. We're looking at about maybe an hour for sorry guys. We're going to be talking maybe an hour on the webinar here, probably closer to 45 minutes. What I want to do is leave enough time that we can talk about any questions that might come up during the course of the webinar. So we can't talk about how it's more sustainable until we actually talk about what it is, specifically what is a multi-purpose system. And then what does Uponor use to make a multi-purpose system more sustainable, and what materials are used in that installation. So all of these three things we're going to discuss at length, and then we'll do some comparisons to other types of systems that are out there. I think that's par for the course. We need to talk about what is being used right now and what could be used to make these things greener. So Mike mentioned that it's Fire Sprinkler Week next week, and actually all of October is Fire Sprinkler Month. So you'll see, if you're involved in Cub Scouts or Girl Scouts or any other sort of organization like that, and you're trying to get education out there for the people in that organization, this is the time of year where most fire departments are geared up and ready to do presentations for your groups. What we're talking about from a fire sprinkler standpoint is a life safety system for 1- and 2-family dwellings and townhouses. That's really where our product, the Uponor Aquapex tubing, is best used. So they're becoming more popular. I would imagine some of you are part of building organizations. Some of you might be part of plumbing organizations, and some of you listening today might even be part of a fire sprinkler organization. What has happened, or what has changed in the nation over the last decade, has been that fire sprinklers are now being installed in residential houses. What happened was, back in 2009, the International Code Council got together and they put fire sprinklers to a vote. The vote passed, and in 2011, it became part of the International Residential Code. So any house that's built to code or built to the model codes has a residential fire protection system in it. Some states, some municipalities have been slow to adopt those requirements. Some have phased them in increments. Certain houses will get sprinklers, certain ones won't for now. But ultimately, what we're looking at is a a system that's going to be installed in every home over the course of the next couple of decades. Now, what I'm not going to talk about today is what makes fire protection as a whole more sustainable or makes it more greener. More greener? I don't even know if that's a word. But Eric Scari from Uponor did a Green Builder webinar all about the ins and outs of fire protection systems and why they are a more sustainable system when they're installed in a residential house. And I encourage you guys to go to Green Builder's YouTube channel if you're impatient. But if you're patient enough, they're going to include the link on the follow-up email for you guys. So state municipalities have been slow to adopt them, but they are coming. I tell contractors this all the time. In 30 years, fire protection systems are going to be like plumbing systems were 100 years ago. 100 years ago, you wouldn't necessarily install an indoor plumbing system, but now you wouldn't install or you wouldn't build a house without one. And that's going to be the way it's going to be in 30 years or so. So what is a multi-purpose system? Well, Mike, you stole a little bit of my thunder at the beginning. Multi-purpose system is basically a fire sprinkler system that is incorporated with the domestic cold water system. And think of it this way, I put the graphic on there for a reason. It's a Swiss Army knife. It's got in there a file, it's got a blade. On one side, I've got a pair of scissors. On the back side, there's a pair of tweezers. And on the opposite side of that is a toothpick. I wouldn't go to the store if I needed all of these things and buy them all separately. It would just make more sense that I carry them all around with me at once in my pocket in one convenient tool. However, I got to warn you guys that the toothpick on a Swiss Army knife is a one-time use thing. There's a reason why we buy them in boxes of 1,000, because reusing a toothpick is nasty. I guess you could get another use out of the toothpick if you flip it over to the other pointy side, but just a little food for thought. So this is an example of a multi-purpose system. It looks like a piping system where we're running a big loop around the perimeter of the house and picking up all of the sprinklers as we go. Not only that, when we pass by a bathroom group, and I've highlighted the bathroom on the left-hand side of the plan, we'll pull off of that sprinkler line to a T or a multi-port T or directly to a fixture that supplies all of the plumbing fixtures in that room. So on this image, I have an Uponor multi-port T, and I would pull off of that to supply the water for my toilet or to my bathroom sink or to the shower. This uses both piping systems to do two jobs: a small amount of piping for the plumbing system to pick up the plumbing fixtures, and a majority of the pipe is supplying all of the needs for the fire sprinkler system. Now this contrasts a different type of system that is primarily installed in the United States, which is called a standalone system. Standalone systems use piping for sprinklers only. Now, because you're using piping for sprinklers only, you're going to need to put some sort of check valve or double check valve or some other type of backflow prevention device on that system to prevent the yucky water from mixing with the yummy water. Okay, so we don't want any of the sprinkler water to mix with the potable water. And that can happen in the house where that separation occurs. And sometimes they bring a separate line all the way out to the street and still put a check valve on that or some sort of backflow prevention device on that to make sure that the sprinkler water doesn't get back into the municipality water. Because of that backflow device, whether it's a check valve or backflow preventer, there are a couple of things that occur when you use that. It's going to create friction loss, for one. And friction loss will just make less pressure available for the sprinkler system. They're all sized hydronically, so what's going to happen is when you install a flow restricting device like a check valve or a backflow preventer, you have to increase your pipe size downstream of that device. Bigger pipes mean more materials and sometimes harder installation, and that's just one of the reasons why they're not as sustainable choice as a multi-purpose system. Multi-purpose systems primarily utilize very small pipes. Because of the loop configuration, we're probably going to deal with 3/4 inch. Most of the sprinkler systems that Uponor designs are 3/4 inch, and some of them end up being 1 inch, but none of them get any larger than that. So it's a 3/4 inch or a 1 inch system all the time, and that's going to make estimating those systems a lot easier too. So backflows can cause another problem too, not from just a restriction standpoint, but backflow preventers require maintenance. So annually, you'll have to have someone, whoever did the installation or is licensed to do backflow inspections, come to your house and inspect the backflow preventer to make sure it's functioning properly. Now, the other option is to not get it maintained. When you don't get it maintained, you save a lot on the maintenance costs, but you could end up replacing the device later on because it malfunctions. And if it malfunctions, that means you've got some of the yucky water mixing with some of the yummy water, or you have a fire sprinkler event where your backflow preventer didn't open. And that's more dangerous than actually having it maintained properly. And then when you have it maintained, you get into the nitty-gritty of how much fuel is required to send someone out to the job site annually to maintain it. That's money out of your pocket for those maintenance fees. It's better just to have a fairly maintenance-free system. All right, so this plan I worked up has all of the things we need to design and install a fire sprinkler system. And what we'll do is we're going to walk through a side-by-side comparison of a multi-purpose sprinkler system utilizing Uponor Aquapex tubing, and we're also going to look at a traditional standalone application using CPVC pipe. On this comparison, we're not going to include the garage. Garages do not normally need to be sprinklered. We're also not going to include sprinklers in closets that are under 24 square feet, nor are we going to include bathrooms that are under 55 square feet. We do have another webinar available that deals with the ins and outs of fire sprinkler design. Melissa Rodriguez with Uponor did a webinar about a year ago, and that is also at Green Builders YouTube channel. And if you have the patience to wait around for the link, they'll be sending it in a follow-up email as well. So it's important to look at this sprinkler comparison for the webinar. We really do need to see what goes in and what could go in instead. All right, so from here on out, if I say PEX, what I mean is Uponor Aquapex piping. From here on out, if I say CPVC, I mean CPVC because there are a lot of different manufacturers of CPVC pipe. But specifically, the stuff that's rated for fire protection on the CPVC end will be the orange CPVC pipe. It's important to talk about Uponor Aquapex tubing only, and to preface that when I say PEX, I mean Uponor Aquapex tubing, because not all PEXs are created equal, and not all PEXs carry a listing for residential fire protection. So you couldn't just go to a Lowe's or a Home Depot or any big box store and purchase PEX tubing and install it in a fire sprinkler application. It has to come with a specific listing, and Uponor's is listed for that specific application. All right, so what we'll look at is how sprinklers lay out in these two buildings. Here we're looking at the upper level. It's going to be pretty much the same because the rules don't change depending on what material you're using from a standards standpoint. And another thing that we're not going to look at is pipe sizes aren't accounted for on this comparison. The plumbing comparisons that we do, they're going to be the same material because you would normally install, or at least that's the way it's trending, that you would normally install PEX for the residential domestic water application, but the systems will look different because we're going to have a standalone plumbing application with a multi-purpose plumbing application. And I'm also not going to include the pipes for the connections between levels because that's just a little bit redundant, and I was maybe a little bit lazy too. So here we go. So I have the sprinklers laid out. Again, small closets aren't sprinklered, small bathrooms aren't sprinklered. I've got 10 sprinklers on the multi-purpose side and 10 sprinklers on the standalone side. So when we pop down to the basement, things are going to change a little bit, and this is the first time where we start to split paths from a sustainability standpoint, because we're going to start using more material on the standalone side. Down below, I've added another 7 sprinklers on the multi-purpose side and an additional 9 sprinklers on the standalone side. And this all comes down to what we call, exposed listing. So this basement is unfinished, and we want to install the piping in an unfinished application. Well, in order to do that, you need to have a listing that says you can install it exposed. And most piping manufacturers will have a specific listing for exposed. CPVC manufacturers have exposed listings, and Uponor Aquapex tubing has an exposed listing as well. Let's take a look at Uponor's and why we can use fewer sprinklers with an Uponor system. So UL 1821 is the listing agency for exposed applications, specifically for thermoplastics. We can use our tubing in any type of structural configuration, so it can be dimensional lumber, or I can use it in wood I-joist applications. I can use it in floor truss applications as well. The only additional requirements that we need for this exposed applications is we need to use metal pipe supports. Those are spaced every 24 inches on center, and the sprinklers that we use in this application, they also have to have a rating of somewhere at 155 degrees or less. So when I look at a CPVC application, I still need the sprinklers at 155 degrees or less, but I also have to use smaller spacing for those sprinklers. And this is why we had 9 sprinklers instead of 7 sprinklers, because I'm limited on how those sprinklers can be spaced in that basement application, depending on which way the joists are running. I also have directional limitations. So when we actually get into the layout of the systems, we're going to see that the mains have to run a certain way and the branch lines have to run a certain way in accordance with the listing. And this actually adds more material to it, because as we look into the different configurations of standalone systems, we're going to see where we can't necessarily drill through joists to make shorter distances for ourselves. So that's true for dimensional lumber. That's true for wood I-joist applications, but for the most part, at least the last time I checked, which was really recently, CPVC is not rated for floor truss applications. This means that they'll have to put a 15-minute fire barrier underneath to act as a lid to separate the unfinished area from where the piping is installed. This fire barrier can be gypsum or it can be plywood. The rules for the 15-minute fire barrier come out of the International Residential Code. You're looking for section P2904. Okay, so back to the plans. We have 17 sprinklers on the PEX side and 19 sprinklers on the CPVC side for the basement. When we look at how these systems are installed, this is where we are worlds apart. So when we look at the main level, we're going to have a piping configuration that looks a lot like this. So PEX tubing is flexible. We can bend around things that get in our way. For the most part, when we design and send a material list out to a contractor, we don't include any elbows for that installation, because the installation can be done without adding additional fittings to get around corners. So basically we go from sprinkler to sprinkler. The piping comes in large coils. So for this project, let's say we use a 300-foot coil. When I'm installing the pipe between sprinklers, I will take the coil and I will measure out how much pipe I need on either side of, or to connect the 2 sprinklers together, and that's it. Whatever pipe I don't use, it goes back in the coil, or I use for the next sprinkler. So there's no waste produced when I'm piping a system using large coils like that. The fittings, I have 10 sprinklers and I have 10 fittings. That means that I'm going to be able to take those sprinklers and bring them down to the ceiling level and use the flexibility of the tubing. I'm going to get to that on the next slide. I only have 20 connections. That's 1 connection on each side of those fittings, and I'm not including the threaded connections for the sprinklers on this comparison either. So when I'm installing PEX tubing above a structure, what happens is when I go over the top of the bottom cord of truss, or when I drill through a joist, I have to drop down to the ceiling level. Well, the pipe is flexible enough that we can just do that using the flexibility of the tubing. So I don't need to cut a drop in for that sprinkler. That eliminates an additional fitting at a higher level to get down to where that sprinkler needs to be. And then when I need to go up to a new hole that I've drilled to get through the structure, I just use the flexibility of the tubing to get back up there. On the CPVC side, things look a little bit different because CPVC is a rigid piping system. So anytime I need to make a turn with the pipe, I have to install a fitting. When I look at the CPVC side-by-side comparison, I can see elbows where I need to turn and pick up sprinklers. Now this is where, and this is why actually, larger pipes are usually required for standalone systems. I don't have the benefit of having water delivered to the sprinkler from 2 points. I'm either going to have the water come in on one side of the building or the other side of the building and pick up all of these branch lines. Now it can be done in a loop configuration like I did with the Uponor PEX tubing, but that's not the way that it's typically installed. It just doesn't make sense from a cost standpoint to install a loop with CPVC piping. So for the drops on this, you'll see the sprinklers, you'll see the pipe, you'll see the fittings are way more than what is required on the PEX side, also the connections. The reason is when I get above each one of these sprinklers, because I've drilled a hole higher than where the sprinkler elevation is, I have to install a drop and then a special fitting, a special sprinkler adapter at the bottom of that drop. This is what a typical CPVC drop installation would look like. So I have my main line running to a branch line, so I need a T to get over to that drop. And then once I get to that drop, I need another sprinkler adapter. So if I'm looking at the connections on this, at the T, I've got 3 cement connections. At the drop, I have 2 cement connections for that elbow, and then I've got 1 additional cement connection where that sprinkler adapter is. All of this piping can be dry fit. When I say dry fit, what I mean is I can put the pipe inside that fitting without adding any glue to it. When I've got it installed like that, it looks like the connection is made, although the connection might not be made. And I may forget about dry fitting that fitting. And then later on, when I go to test the system, the fitting will blow off and I'll get water everywhere. This doesn't happen on most job sites, but it's happened to most contractors where they've had a fitting that wasn't glued and it blew off either before the sheetrock was up or after the building was finished. And that really digs into the bottom line and it ruins a lot of material in the building. Uponor piping can't be dry fit. The inside diameter of the fitting and the pipe are the same. The only way to get the fitting into the pipe is to expand it. If you're curious about the Uponor ProPEX connection system, I encourage you to go to Uponor North America's YouTube channel. You'll find all sorts of videos there about how connections are made in systems. So back to the sprinkler system comparison. This is the upper level, and we're going to drop down to the basement now and take a look at how these systems stack up. The reason there's more waste on the CPVC side is because CPVC comes in straight lengths, 10 footers or 15 footers. As you get near the end of those straight lengths, there's small pieces of pipe that you just can't use. Just to be fair, I did use a lot of the waste that I calculated on material for those drops. So I took away some of the waste that was factored into there. So I'm not a big meanie, okay? I'm going through as fairly as I can here. So in the basement, the configuration for the Uponor AquaPEX side is going to look real similar to the upper level. We have a 1 loop coming around, picking up all of the sprinklers. I've got an additional fitting there that I wouldn't necessarily have on the upper level, but that's because I need a supply line running from my water source. So now we're up to 233 feet of pipe. We still haven't used all of that 300-foot coil, so I haven't produced any waste. Anytime I make a cut, I just start where that cut ended on my next connection. We're up to 18 fittings for the multi-purpose system, and we have a total of 37 connections. Over on the CPVC side, we're adding more pipe, we're adding more fittings, and to eliminate or to cut down on a lot of the cement connection, I installed crosses down the center of the building. And this is a more conservative way to install. It utilizes less pipe. So I've got fewer fittings when I use a configuration like this. My sprinklers are still 19, that hasn't changed. I'm up to 217 feet of pipe. I've got 50 fittings, 96 connections. All of those connections could be dry fits, and I've got about 25 feet of waste. So from a total installed perspective, just looking at the sprinklers, we're using more pipe on the Aquapex system, and that's mainly because we have to pipe it in a loop, and we're using less pipe on the CPVC side. But when we factor in waste, it actually becomes more pipe, and the material involved in those fittings and connections really does put it over the top. The other factor that we're not looking at, that I alluded to earlier, is that we're not looking at size. Because the hydraulics work so unusually on a tree system, I can't get down to a small pipe size across the board. So depending on what my incoming water pressure is or what my design configuration is, I may be installing 1.5 or 2-inch pipe for some of these main lines. But that's nothing I can compare unless I'm doing a hydraulic calculation, and we don't have enough time for that today. It's not very interesting anyway, so I'm saving you guys a lot of headache. So on the PEX side, what we're going to do now is start incorporating some of those plumbing fixtures. Now, what you're looking at are not all of the plumbing fixtures for the house. Some plumbing fixtures we're going to take off of the upper level, but I have included most of the lower flowing fixtures that we can get from the basement. When I start tying these into the sprinkler system, I'm going to use multi-port tees. So for instance, the 3 fixtures on the top, I've cut a T into the fire sprinkler loop, and I've piped a little bit of 3/4 inch out to a multi-port T, and then I'm using 1/2 inch tubing from there to pick up all of my fixtures. On the bottom side of that same line, I've included a flow-through multi-port T, where I'm picking up a toilet, a sink, and the washing machine, it looks like. On the upper level, I'm going to use T's for the higher flow fixtures. This just ensures that a lot of water is running through the system, because this is the same system that we're using to drink out of. We want to make sure that the water is always fresh in those lines. Now, it doesn't matter where the fixtures are flowing in the house. If I open a fixture in the basement, it's still going to circulate the water on the upper level. Again, if you want to go to Uponor's YouTube channel, we explain why that is, and we actually show you how it works. But for this upper level, our design practices include using these lines above to pick up the high flow fixtures. So we're picking up a washing machine. I think the fixture we picked up before in the basement was the dishwasher. And then we're also picking up the showers and the bathtubs on this level. So if you look below, you'll see that I've separated the pipe out from a sprinkler and a plumbing standpoint. So we have 233 feet of, say, 3/4 inch pipe for the sprinkler system, and a mixture of 3/4 inch and 1/2 inch pipe for the plumbing system, equaling about 62 feet. I'm still not over that 300-foot mark for that 3/4 inch pipe. In fact, I've used probably only, a few extra feet of 3/4 inch pipe. So I haven't produced any additional waste, and these are the fittings and connections that are included with that. So on the standalone side, we're not going to be tying into any lines because it's a standalone system. So I've got standalone sprinklers. I also have standalone plumbing. So the plumbing system, because I don't have to really concern myself with circulating water anywhere in the system, I'm just going to install all of the plumbing fixtures from below. Because of that, I'm going to have a lot more piping for my supply lines. So I'm doubling up on my supply lines when I have to install these in a standalone application. I'm still using multi-port T's. I'm trying to create as few connections as possible. And really, I'm only adding 3 fittings on the standalone side. So I still have 50 fittings on the sprinkler side, adding 3 fittings for the plumbing side, a total of 53, and then an additional 23 connections on the plumbing side. And then we're still looking at that same amount of waste. We didn't add any more waste for the plumbing system because, again, we're using Uponor PEX tubing. We're just going to cut it out of the coil, and whatever we don't use, we bring to the next job site. So this is the overall comparison from a PEX system to a standalone system when we're utilizing or when we're using pendant sprinklers everywhere. And what we're going to do next is look at a sidewall configuration, because that is actually what's mostly installed in the United States are standalone applications with sidewalls on the upper level. Before we get to that, I want to pause and answer any questions that we've on the content that we've covered so far.
All right. We do have a question from Oren wanting to know if this is going to work in 6 to 8 unit multifamily dwellings.
Okay, yeah. So good question, and I have to make some assumptions here. When we're talking about 6 to 8 unit multifamily dwellings, they have to be configured like a townhouse. And townhouses have a specific limitations in NFPA 13D, the standard that governs the installation of 1 and 2 family dwellings in townhouses. They have to be open from the slab to the underside of the roof. So I can't have stacked units. And also I need open space on at least 2 sides. So if we're looking at an 8-unit townhouse in a row configuration where I don't have units on top of units, then yeah, it can. If I have a 8-unit townhouse where I have 4 units below and 4 units above, then no, it wouldn't be able to. That would be a different standard where we don't have a listing with our product. And also, if this was an 8-plex where I had 4 units on the front of the building and 4 units on the back of the building in a back-to-back configuration, well, I would only have open space on 2 sides on the corner units. The middle units, the 2 middle units on each side, I would only have 1 side open, and then it wouldn't meet the requirements of NFPA 13D. At that point, we would switch to NFPA 13R, and you would be looking at a different type of material at that point.
Okay. I also had a question for you, Dan. You detailed a house here that's got a basement underneath it, and I'm going to show my ignorance here, but I know you can answer this question. For homes with crawl spaces, does that level require sprinklers too, or does it kind of depend upon how deep the crawl space is, or how does that work when you have a crawl space?
There's only one time when you would ever install a sprinkler in a crawl space. The requirements say that if there is fuel-fired equipment in the crawl space, such as a furnace or a fuel-fired water heater, then you would need to put a sprinkler directly above that fuel-fired equipment. But you wouldn't have to include them anywhere else in the crawl space. That's a great question. Gotcha.
Okay. And then we also have a question from Douglas. Douglas is a builder, and he points out, and rightly so, that homes that we build are getting better each year. He says that they're less flammable than in the past, though the contents inside the home, they are still very flammable, and I think of curtains especially. He points out that a lot of municipalities do not choose to adopt the sprinkler code or the sprinkler as part of their local or state code requirement. But he says the issue is more on the life safety side, not so much saving a burning house. I think as it pertains to code, I don't think on a general level, I think we all want to obviously save a burning house. It's more on if you're looking at it strictly through the code lens. He understands that the NFPA code for residential sprinklers states as long as he has flow at the furthest point, he meets that standard, but he wants to know if that is correct or not.
So flow at the furthest point, maybe that requires a little bit of clarification, like for the fire sprinkler. There is a specific amount of flow that each sprinkler needs to operate properly, and those are detailed in the requirements of 13D and also the sprinkler manufacturer's listing.
Okay.
So it's not just about water coming out of the sprinkler. It's the right amount of water.
Okay. And the reason he's asking is because he is installing residential sprinklers on all his new projects, both new and remodeled homes.
That's great. That's great. And go ahead. You finish.
Well, I was just going to say he wanted to add that he states that he's not required to install them, but he says that they are cheap when installed into the domestic water system, like what you're talking about.
And the more you install sprinklers, the better you become at installing them too. And there's that cost benefit there as well. I do want to touch on a point that was made earlier regarding stating that houses are being built better with less flammable material, and that's true. And the problem really plays into not saving the house, but saving the occupants. And if you look at any state's statistics on fire sprinkler deaths, you're going to find that a majority of the fire sprinkler deaths, or not the fire sprinkler deaths, but fire deaths in dwellings are the very old or the very young, usually those with mobility problems. And it's not necessarily the structure that's unsafe, but really the ability of the occupants to get out of the house in time. And more often than not, a lot of people are found near the exits of a home. So what we're trying to do here is give the occupants enough time to get out of the house. And although houses are built safe, you do have people that do a fair amount of sweat equity on their house. And you really sweat when you've done electrical work in your house. So it's the sweat that you produce when you're doing the installation, and it's also the sweat that you produce when you're laying in your bed at night wondering if you did the installation right. So as houses age, they become less and less safe too, because the occupants are doing more work in the house.
And I wanted to add one thing, Dan, and that is, it is in the form of a question, but when we talk about sprinklers, certainly there's a code angle, there's a cost angle. I personally always like to think of cost as the cost of ownership rather than just the cost of buying a product. And I don't know if you're going to touch on this later in the presentation or if now's the time to address this, but there's got to be a benefit to the insurance premium if you're installing a sprinkler system, because yes, life safety is of the utmost importance, but the contents of the home itself, there's a value there too. And it's certainly reflected in your insurance premiums and in your insurance policy. So can you speak to that now, or is that something you're going to cover a little bit later?
No, I'll talk to it now because I wasn't going to include it. And I can only speak anecdotally on this because all insurance companies are different. I did an installation on my old house, which was built in 1950, and I got a 8% insurance break. The 8% insurance break that I got was from a basement-only installed system. So I only did the sprinklers in the basement, but still was able to save about 10% on my overall insurance cost. If I had done the whole house, it would have been 15%. So there is a definite benefit there. Plus, the resale value of the house comes into play as well. If I am looking at two houses and one's got sprinklers and the other one doesn't, I think the house with the sprinklers is going to be more appealing to me.
Gotcha.
So let's move on.
Yep, let's continue.
So here we're looking at a sidewall comparison. Now, a lot of installations from a standalone standpoint are installed like this because there are concerns with installing piping in an attic configuration in cold climates. So for this, we're using the piping in the basement, and then we're rising up on the interior walls to pick up the sprinklers. I haven't really added any sprinklers here. I was still able to do it with 10. Usually it does increase the amount of sprinklers just because you're dealing with corners and basically sprinklers that spray in one direction. And I want to point out that in the lower right-hand corner, I have the sidewalls kind of out in the middle of the room, and there's a reason for that. I'll get to that. So it looks weird right now. When I start adding pipe to this, I'm going to rise up in the wall, and then I use a special sprinkler fitting that's back-to-back. So I'm just using a couple threads, and I haven't included those threads on the connections. So the amount of connections so far looks like a lot fewer connections than when we were doing the standalone system using all pendant sprinklers. But because of the location of the very lowest sprinkler in this upper level, it's on a cold wall, and I wouldn't necessarily want to install that pipe inside the cold wall. So I would pop the pipe out and build a soffit around it. So I included the soffit in the waste category because it's really not necessary when you're using a multi-purpose system to worry about cold walls or things like that. We have a bunch of guidelines regarding Uponor PEX tubing installed in attic configurations. I would say that you don't have to worry about how that's installed as long as you follow the Uponor guidelines for that. So there is a wasted soffit, I want to say, in the waste category for sidewall applications. When we get down to the basement, the plumbing layout hasn't changed at all. That's going to be the same. So when we look at the plumbing numbers, they're going to be exactly the way that they were before. The waste number for sidewalls go up because as I drop down to the lower level, I'm going to have to cut off the end of each of those lines to match the level of the mains that are run there. And because I can't cut into one of those branch lines and move over due to the nature of the exposed listing, I'm going to have to run all of the branch lines parallel with the joists below. So that means more piping and in a lot of cases more connections. So I can't utilize crosses at this point because I can't go perpendicular to the joists. I have to run parallel with them. So the bottom line here is that we're looking at 224 feet of pipe, still that 170 for plumbing, 44 fittings, 88 connections, and about 25 feet of wasted pipe plus an additional soffit that we have to build to house the CPVC tubing. So in both instances, more material is used, but that's only on a material standpoint. What we really need to talk about is how does that impact the job site overall? Oh, hold on. There we go. I had a technical difficulty. So I've got contractor 1 who is hired to do the plumbing work, and I have contractor 2 who is hired to do the fire sprinkler work, and they are driving different vehicles. The reason they're driving different vehicles is contractor 1 can fit all of the piping that he needs into a small car. I used to say that I can fit all of the material I need for a sprinkler project in the trunk of my Jetta when I'm doing a multi-purpose system. So very small coils. On a standalone side, you're going to be dealing with 10-foot or 15-foot pipe that has to go on top of a truck or a van or something that can house that pipe. I wouldn't be able to, well, I could probably carry it on the top of a Jetta, but I would look ridiculous. So we also use very few tools. We have a Milwaukee tool that we use to expand the pipe and a simple cutter. These are what I need to do a sprinkler installation. I'll still need a drill and stuff to mount the sprinklers, but this is pretty much it to do all of my piping connections. On the CPVC side, I'll need glue, I'll need some sort of cutter, and I'll need some sort of reamer to ream the pipe. That's still very few tools to do an installation. However, on the left-hand side, the multi-purpose AquaSafe installation is an all-climate installation. I can do expansions in any weather from 100 degrees to 40 below. It doesn't matter, and it doesn't affect the way that the connections are made. In fact, in cold climates, I get to do fewer expansions. On the CPVC side, I need temperatures above 50 degrees Fahrenheit. To use the glue's got to be stored above 50 degrees, and it won't work properly if it's not in a 50-degree environment. If it ever freezes, it's not going to work properly after that, even if I'm installing it in an above 50 degree environment. The ratcheting cutter, I can't use below 50 degrees because it creates environmental stress cracking on the CPVC. So at that point, I have to use some sort of chop saw or hacksaw to cut through the pipe, or a wheel cutter would be acceptable too. So if I don't have an environment that's above 50 degrees, now I have to produce heat for that installation. Usually heat comes out on the job site when the mud is being installed on the sheetrock. And at that point, it's usually insulated. So this would be heat on the job site before insulation is installed, and I have to maintain 50 degrees. There's going to be a lot of heat leaving that building while that installation is going on. So looking at contractor 1, our multi-purpose contractor, first we're going to experience fuel savings, both in the amount of energy to transport the material, and if I'm doing a winter installation, I don't need to pipe heat to the building. There's fewer job site conflicts. My first boss that I ever had, first week on the job, he said, Dan, he who is there the firstest moves the leastest, and that was Frank Winicky when I was working for General Sprinkler Corporation in Maplewood, Minnesota. And he's right. If you're there first and someone else comes in after you, they're going to have to move, and you don't necessarily have to move. unless they cut your pipe down, and then that's just a change order, which we like in the construction industry. So it means faster completion too. If I'm doing the work of 2 trades, I don't have to wait for another trade to get in and get his stuff in place so I can do my work. When I am dealing with changes to the job site, I'm really only affecting 1 trade with a multi-purpose system. So that means fewer change orders on a project as well. Less wasted material when I'm doing the installation, as we just saw. And finally, less paperwork. Not just from a we're saving the trees standpoint, or but more so from a standpoint of now I have someone who's not doing all of the billing and all of the contract work for 2 separate contractors. Okay, so I'm going to have a little bit of fun with these last couple slides, and we're nearing the end. We're at slide 37. I think I'm slide 42 on this entire presentation, so stick with me. So the age of information has hit us full force. I mean, I can't even talk in this room without my phone thinking that I'm talking to it. So homeowners are becoming more educated, basically. They have access to all sorts of information. So this is just a keyword search that I did using my browser, and I pulled up a couple of images. And I want to show you that now that homeowners know that they may need to put sprinklers in their new houses, they're going to do a little bit of research before they do that. So the keywords used here were residential fire sprinkler systems. Now, traditionally, CPVC has been the big player in the market, but as you can see on this slide, and I'm just going to black out all of the ones that are not associated with the CPVC installation. So there is a lot of houses, a lot of installations that that have alternative materials in them. I think Uponor alone has designed and had installed over 20,000 different sprinkler systems over the last 17 years. The next keyword that I plugged in was sprinkler pipe failure, because people are concerned about protecting their investment. So why wouldn't you type this into a search engine? And again, I'm going to black out all of the ones that are not associated with the CPVC product. And if this doesn't tell a story, I don't know what does. CPVC is a very, very tender building material. When I say tender, if you use too much glue, you'll damage the pipe. If you use ratcheting cutters under 50 degrees, you'll damage the pipe. If you bend the pipe too far, you'll damage the pipe. If you drop it, you'll damage the pipe. If you run a Cat 5 cable over the top of CPVC because of the softeners in that plastic on the Cat 5 cable, you will damage the pipe. So there are a lot of ways you can damage the pipe. And I always say that, how do you know that the pipe that you just got from the wholesaler isn't damaged already? My contention is by the time you install CPVC, you're already installing damaged pipe. So you need a durable product when you're doing fire sprinkler installation. It doesn't matter if you're doing a green multi-purpose system or a green standalone system or a standalone system, you want a pipe that is durable. So Uponor Aquapex tubing is durable. So we have a thermal elastic memory, which we use to make our connection systems. And that memory, that shape memory, is also very important when you're doing an installation. And if you do an installation like I do, you're bound to get kinks because I work too fast and sometimes I cut corners. And cutting corners causes kinks in the pipe. But lo and behold, I can take a heat gun to that pipe and repair it. You cannot do that with CPVC, or actually most other PEX materials are not able to be repaired like that. So if you do have a PEX that has a fire protection rating, but is not repairable, I wouldn't use that, because when you do an installation, you're going to damage it at one point, and that's just more waste that you're producing. Another thing here is the attic installation that we talked about briefly earlier. Our piping will expand to 3 times its outside diameter before it would break. So it's very highly freeze resistant. And if you follow the Uponor attic installation guidelines, you shouldn't see a freeze ever anyways. And we've been doing this for 17 years, and freezes are just not something that occurs. And we do installations as far north as Fairbanks, Alaska, with the piping installed in the attic. So to sum things up, we'll be ending here in one slide. I just want to go through the different things that we've talked about. Multi-purpose systems. They're two systems in one, which means I can use one contractor. And if I have a plumbing contractor that I've used for years and years and years, well, plumbers can do the installation of multi-purpose systems. They just need the proper training, which Uponor will provide. AquaSafe multi-purpose systems specifically use Uponor Aquapex tubing that is very, very durable and very easy to work with. We have a fully exposed listing, meaning that if I encounter a building that has floor trusses, I'm never going to have to put a sheetrock lid under there in an unfinished application. It's flexible, so I can use fewer fittings when I'm doing my installation. There aren't any elbows required to turn a corner. It produces less scrap when I'm using coils. Now, if I use PEX and straight lengths, I'm going to have similar scrap value or similar scrap to what I had in a standalone application, but I never teach people to use straight lengths. I always teach them to use coils. It means smaller pipe sizes. Again, Uponor systems are usually 3/4 inch or 1 inch. We don't even make sprinkler adapters for sizes larger than 1 inch. And all of our systems, no matter how big the house, work at relatively the same pressures. And finally, we can't dry fit our system. And that really does make for a more sustainable building later on. I won't have water damage in my house if a fitting blows off of a pipe. All right, everybody. So I was Dan Hubbard and will continue to be. You can reach me at dan.hubbard@uponor.com. And my phone number is 952-997-5325. We're going to open it up again for questions at the very end. And I want to urge you to ask questions now, and I'll stick around for as long as it takes to answer all of the questions. But if you have a question and you think that, okay, I'm going to ask Dan in an email privately, then you, sir, are a jerk, because everybody benefits from people asking questions in these things. So if you do ask me a question in an email, please preface it with, I thought of this after the webinar, not during the webinar. Otherwise, I'm going to chastise you just a little bit. But it's all in love, because we at Uponor love people that build greenhouses, and we love people that do multi-purpose installations. So I'm going to hand it back over to you, Mike.
All right, thank you, sir. So we've got another question from Douglas. He wants to know if the NFPA standard requires that his plumber use a sprinkler rated pipe.
The standard is, well, first off, the standard's real nice because they try and eliminate as many things requiring a listing as possible. So things like check valves and control valves and hangers, they don't need to be specifically listed for fire protection. Even if I need a pump on the system, I don't need a fire protection listing. The things they do require are the pipe, the fittings, and the sprinklers. So those are the big three categories where we need absolutely a fire protection rating. And the rating is going to be UL 1821. And that should appear on the side of the pipe in the print stream.
Gotcha. So I had a question going back in the early part of the presentation. You don't have to move the slides back. I'm just referencing a point in time here. You mentioned that you weren't putting sprinklers in the garage. Does the IRC not require sprinklers in the garage? Because that would seem like a logical thing given the presence of flammable products like gasoline and oil that you typically find in a garage.
Well, back to Oren's point earlier, he said that that we're trying to save the occupants in the house. So really, the worst time for a fire to break out in your house is when you're asleep. And really, you just want to get to the front door. Now, a fire may occur in the garage, but you're still going to have the time to get out of that house, provided that you're not exiting through the garage. So you're going to be required to have some sort of other point of egress in the house anyways. And that's where you would go. The tricky thing about garages is that there's not necessarily always a heat in the garage. And so if you run pipe over an unheated area, it doesn't matter if you're using PEX or CPVC, you're going to run the risk of freezing that pipe. So as much as NFPA 13D, as much as that committee has been able to do, they've pulled back a lot of requirements to keep the cost of these systems low. We start adding sprinklers to the garage, we're going to see increased prices on our sprinkler bids.
Okay, makes sense, makes sense. All right, we're going to get technical here, Dan, so we're going to test your technical prowess.
All right.
Know, if he loops an Uponor 3/4 pipe, can he branch off with a 1/2-inch line to feed the sprinkler heads if I get the flow and the water spread from the head, or does it have to be fed from a 3/4 line?
The answer, the short technical answer is yes, you can do it. 1/2-inch through 2-inch have been listed for use in residential fire protection systems. So we can use 1/2-inch pipe. You are going to run into some flow restriction in that 1/2-inch line, especially since we're not feeding the water from 2 different paths now. We're just branching off and picking it up. So the water is going to be screaming through that pipe. Potentially, you're going to run into a velocity problem at that point too. So I would not recommend it, even though it's technically possible.
Okay. I'm going to throw a minor technical question at you. What pressure should the water be coming into the house if you've got a sprinkler system? I know there's some ranges out there, you know, in different localities. What's kind of the optimal pressure? Just normal, like you would normally find, or does it have to be slightly higher? Can you talk about that a little bit?
Yeah. So I can talk to the base of riser pressure. So this would be the water, where the water comes into the house. Mm-hmm. For a 3/4-inch system, we can make those work with as little as 45 PSI residual. So that's while we're flowing the required amount of water, roughly 26 gallons a minute. For a 1-inch system, we need somewhere around 20 to 35 PSI residual, and there's a big range there. And it all comes down to how the piping is configured in the building. That's going to be pretty much across the board, from a 1,000 square foot house to a 10,000 square foot house. If I'm doing a 3/4-inch system, somewhere around 45 PSI residual. Where the problem comes into play is, how big is the underground coming into the house? If I have a small underground, it's going to eat up a lot of the pressure that I need for the sprinkler system before it even gets to the house. And that's why I said residual, because we don't know until the water is flowing. You know, one thing that's beautiful about Uponor's design team is because they've done so many of these systems, they know, okay, if I've got 45, 3/4 will work. If I've got 1-inch, I need 20 to 35 PSI, and I can make that system work. So it takes about a 5-minute conversation with the design team to figure out if your underground is big enough to make those pressures work.
Okay. You mentioned Uponor, and I wanted to ask a question about Uponor. Does Uponor provide training for plumbers? And then a follow-up to that is, are there industry associations that also offer such training?
I personally teach a fire sprinkler class here at the Uponor factory. We have 2 trainings that are requirements before plumbers can install fire sprinkler systems. One is called AquaSafe Level 1. That's a classroom code training. And the second is AquaSafe Level 2. Now, that's the hands-on portion of the fire sprinkler training. So at the factory, we build a system here in the factory and flow water through it. We could also do those trainings as a field training. So if a person goes through AquaSafe Level 1 and then wants to install a project, someone from Uponor, either an Uponor employee like myself or one of our sales reps, preferably from the region where the installation is taking place, will be out the job site as well to help out with the hands-on portion of the installation. It doesn't make a lot of sense, though, to travel to the factory and just take the AquaSafe Level 1, because the Level 2 is included in that same day training. It's a 1-day training for both. What some people have the option of doing is going to our website, which you can see on the screen there, uponorpro.com, and click on the training tab, and there is an online training option for AquaSafe Level 1 as well. It costs $50, and you are required to purchase beforehand a copy of NFPA 13D so that we can more successfully teach what's in that standard. And then after that, if you want to get AquaSafe Level 2 trained, that's where the Uponor employee or sales rep would come out to the job site and train you on the installation.
Gotcha. Well, I don't see any other questions in the queue, so I want to go ahead and thank you, Dan, for sharing all this great information with us today. And I also want to thank our audience for attending and asking great questions. And finally, I want to thank Uponor for their sponsorship of today's webinar. Do you have any parting thoughts for us today, Dan?
Sprinklers save lives, and we're going to be hearing that all during the month of October.
All right. We're going to see everybody back here 2 weeks from today. We're going to be discussing home energy ratings and how they can generate more customers for your business. Les Lazarek of Home Energy Connections will be joining us for that discussion, and that webinar will be sponsored by PowerShift by NV Energy. Until next time, take care, everyone. Bye-bye.